Today we are going to understand a topic from the data structures called counting binary trees. Counting binary trees refers to determining the number of distinct binary tree structures that can be formed using a given number of nodes. It is a common problem in combinatorics and computer science, and involves calculating how many unique arrangements of binary trees are possible for a specific number of elements. First, let's start with the basics. Let's understand what is a binary tree. A binary tree is a hierarchical structure where each node has at most two children, a left child and a right child. Counting binary trees means finding out how many distinct binary tree structures can be formed using a given number of nodes. Let us consider n to be the number of nodes. If we have just one node, there is only one way to arrange it. It's just a single root. Here, let's take the element as 10, and this 10 can only be arranged in a single way. If we have two nodes, we can place one node as the root and the other as either the left or right child. Hence, there are two possible structures. As you can see here, there are two elements, 10 and 11. And we have make you kinds of binary trees when we have three nodes. The number of possible binary trees grows even more. There are 5 distinct arrangements with the elements, 10, 11, 12. The first tree has 11 as the right child of 10, and has 12 as the left child of 11th in the second tree. The root node 10 has the child node 11 as the right child, and 12 as the left child. In the third tree, both 11 and 12 are the children of 10. In the fourth tree, 11 is the right child of 10, and 12 is the left child of 11th in the fifth tree. 11 and 12 are the right children of 10th. Now, here is the algorithm to find the total number of nodes. First, let's get the size of left tree in recursive function. Next, get the size of right tree in recursive function. Summing up left and right tree with 1, here is the formula given below. Here is the recursive function given. Let's consider this example, where the root node is 70. Its child nodes are 60 and 80. The child nodes of 60 are 55 and 65, and the child nodes of 80 are 75 and 85. Now, let's add numbers to the binary nodes. Hence, the main function can be written like this. After this, the function will be called. Let's see how the algorithm works. If you look at the binary tree, there are some numbers, hence first, 70 enters the function. It will check whether 70 is empty or not. As the function will return 1 and move to 60, at left node of 70, the node does not have null, so it will return 1 and move to 18755th now at 55. The leaf node has value, so it will return 1 and tries to check left and right of 55, which is null. It will return 1 plus 0 equals 1 to 60. After checking all left subtrees of 60, it will move to the right subtree of 60, i.e. 65. As 65 is a leaf node, it will return 1 plus 0 equals 1 to 60 at 60. All left and right subtree will gather up and return 1 plus 1 plus 0 plus 0 plus 1 plus 0 plus 0 equals 3 to the 70 node. After completion of the left subtree of 70, the function will call the right side of 70, which is 80. At 80, which is not null, it will return 1 and moves to 75. As 75 is a leaf node, it will return 1 plus 0 equals 1 to 80. After checking all left subtrees of 80, it will shift to right node. 85 is also a leaf node, which sends 1 plus 0 equals 1 to 80. 80 sends 3 to 70 node. This will all sum up and return number 7 to main function.